Welcome. Thank you for stopping by. Thank you for viewing my videos. I really appreciate it. If you find this video useful, please don't forget to subscribe and give me a thumbs up. That helps with the channel. I really appreciate it. In this video, I will go in details on a BBMPulser 5.5B model. This is a 3.5 Tesla magnetic pulsar that I recently put out and soon to be open source. So far I don't have a circuit yet drawn, but I'm working on it, and soon it will be available for you to see and possibly build one if you can. This is one of the model that if you do decide to build it yourself, it shouldn't cost you much, and it has a great output as far as power. In this specific model, I am trying a new coil. Well, it's a strip coil that I use prior on a BBMPulser 6B and 5.5B, although in this specific one I am testing out a 0.6 millimeter by 15 millimeter wide copper strip instead of 0.5 millimeter. So it seems like I'm able to get a little bit more power out of it, not significant, but instead of 3.5 Tesla, it'll be about 3.6 Tesla or so. Also, I've noticed that this coil heats up a little slower, and compared to 14 gauge wire, this coil cools off much faster. Again, this is the coil that will trigger the muzzle at around 1.5 Tesla or so. And in a previous video I have already showed you how it's triggering the muzzle and stuff, but in this video I'll go ahead and do a quick power test on this coil, and then I'll jump into details on the build and show you how I connected everything. So let's go ahead and do some power test. Let's start. Don't mind my spot here. This is me testing the poison ivy, and seems like I have a little bit reaction to it, but never mind about that. So let's get it started. The unit is powered, is connected to power, and I have my Tesla meter set up to configure to pick up the highest value, and I'm ready. On the count 3. 1, 2, 3. Alright, so it starts with 1.9 Tesla, pulsates about once a second. Let's go ahead and increase the power. So just watch as the power increases. 2 Tesla, 2.2 Tesla, 2.4 Tesla, 2.9 Tesla, 3.1, 3.268. That's about it. So my Tesla meter won't pick up any higher, but I have some more space to go here, and I can increase more to get about 3.5 Tesla out of it. So I'll go ahead and shut it off. Actually, let me pulse so that I can discharge capacitors. There we go. And now it's more or less safe for me to touch inside of this unit. Let me shut this off. Show you the coil. Okay, so here I have a voltmeter that measures capacitor bank voltage, and it tells you what voltage your capacitor bank's charged. Here's the power adjustment. You can adjust between 2 Tesla all the way to about 3.6 Tesla on this coil. Here is the pulse LED. This is the protection LED here, and this is a on-off switch with the power LED here. So let's take a look on the inside. Let's see here. I have circuit here. This is a beeping circuit. Anytime coil gets hot, it will start beeping. This is a 555 circuit to make it beep. Then on a PCB here, this is actually a PCB from 2.4 Tesla pulser, and eventually I will design specifically PCB for this model, but so for now I'm using from 2.4 Tesla PCB. Works well. In the case here I had to make a couple holes, one for PCB, another one for the voltmeter. Also, if you're gonna use this case, I have closed up the USB ports here so that I'm not using them. This is just a top lid that will cover capacitor terminals. Here I have a 12-volt power supply. This is a small power supply to feed the low voltage PCB here. Let me show you the PCB. How it looks. I need to put a bunch of zip ties and tighten everything together. For now I had it untightened so you can see everything. Now on this side here I have two diodes. These are 100 amp 1000 volt diodes. I have them in series so they can withstand a higher voltage. In the back here I have two transformers. These are the microwave transformers, one here, another one here. On the top of them is the resistor. This is a 300 watt, what was the 1.5 ohm resistor. On the back here I have a fan, exhaust fan. And then I have three thermal switches. One thermal switch is here. That's when temperature gets hot inside the case, and if you shut off the unit and if it's hot inside, and the fan will keep on working, exhausting all the heat out of it. This is the switch in case somebody blocked the fan and it gets hot inside. This will trigger the right here is another beeper. This will start beeping. So I have two beepers, one here. This is for coil when it gets hot. This is when it gets hot inside the thermal, inside the unit. Okay, let's move on to the other side. On this side I have thyristor here. This is a 400 amp 1600 volt thyristor. Going to the bag here is 15 amp thermal fuse. This is in a line of 120 volt. As it comes in, it goes through the thermal fuse. So if unit will start consuming more than 15 amp, this will trigger and it could be reset from the back. That's about it. It seems pretty simple. I just have resistor, thermal fuse, a couple thermal sensors, capacitor. This one is 1100 volt, 1350 microfarad capacitor. They are available on eBay, guys. They cost about $75 with about $50 shipping or something, and they're still available. If you look it up on eBay, you will be able to pick up yourself one. And that's about it. As you can see, this unit is pretty simple. Probably the most complicated is this low voltage circuit that I have here. So there you go. Now you've seen it, and I hope that once I put out the circuit for it, you'll be able to build yourself one. So the case is a silver stone. Don't have a model right now, but if you're interested, just, you know, leave me a comment and I'll look it up for a model. I'll show you, I'll tell you what it is. Very quick. Actually, it's already getting long, so if you have any questions, leave your comments down below. I'll try to answer them, and if you like the video, give me a thumbs up, subscribe, and I'll see you in the next one.